Alright, this is James Lewis. We are doing the Rigid Body Kinetics Quiz 6. And the question, a roller has a mass of 1178 kilograms, a radius of gyration of 119.7 millimeters, and is lifted by two ropes as shown. And if each cable has the following tensions: A of 3,105.7 newtons and B of 3,352.3 newtons, determine the angular acceleration of the roll. And then you have that inner shaft that's 100 millimeters. So first off, we'll do our free body diagram. We've got our tensions A and tensions B on the side of those, which the diameter of that bar is 100 millimeters, and the radius of gyration is 119.7 millimeters. We have our tension of A and tension of B and our mass. So first off, we want to find our angular acceleration. We write out our equations. Our acceleration equals radius times angular acceleration, and force equals mass times acceleration. We'll set up our equation, and I did that little arrow wrong, but it should be counterclockwise is the positive direction. The sum of moments equals inertia times angular acceleration plus mass acceleration distance, perpendicular. The net torque, the net tension is 246.6 newtons, and that's going in the direction of A. So that's so A is pulling with 246.6 newtons. We'll go ahead and put in our equation. Our sum of moments is our tension of 246.6 times our radius of 50 millimeters, our half of 100 millimeters there. We've got our inertia for a sphere, which is 1 over 2 times the mass times the radius squared, which the radius of the inertia is the radius of gyration, whereas when we go a little bit later on to our mass acceleration diameter, that is all in regards to the smaller diameter of the actual tension. So anyway, so it's the 1 over 2 1,178 kilograms. I think it was kilograms. Yeah, the kilograms. Times 119.7 millimeters squared. Like we said, that's the radius of gyration, plus our mass, mass times acceleration times diameter, which our acceleration is equal to our radius times angular acceleration, which gives us our mr alpha times radius. And so the left side of the equation stays the same, the inertia times angular acceleration stays the same, and our numbers on the right side of the plus sign become our mass, our 1,178 kilograms times 50 millimeters squared. Again, that's because that's the radius of the moment about the tension, squared times our angular acceleration, and our angular acceleration equals 0.00108 radians per second squared.